Welcome back, folks. It felt like it was about time that we started to talk a little bit about micro front ends, which is why we had to get an expert in the matter. In fact, not just an expert, this guy's a doctor. It's my pleasure to introduce Florian, who is here to talk to you about micro front ends. Florian, the floor is yours. Take it away.
Thanks a lot. Much appreciated. Welcome everyone to my session. Multiple ships to the island. Yeah, we are shipping a lot of things here. Micro frontends and island architectures. Two kind of patterns that you might have heard. You might not know what they are about. In this session, I will shed a little bit of light on both of them, and we see where they differ and where they also come together. Now, a few words about my person. So I'm a solution architect at a company called SmartPiot. We are a smaller company. We are specialized in IoT, creating platforms, digital transformation projects. And I myself, I'm specialized in creating distributed web applications. So essentially helping large teams, get work done. And I'm also, besides my professional work, an open source enthusiast, Microsoft MVP for several years now. I do many projects in .NET and JavaScript space. And I'm also like to write a lot. And in this case, I'm also guilty of having written a book called The Art of Micro Frontends. I only bring that up because, it fits to the topic. So if you think that something that I said makes sense to you and you want to read more about it, this is one opportunity. But let's just dive right into the topic, and I want to start with a little bit of, let's say, a history lesson in how the evolution of web development came along. And there are many perspectives to look at that. And since we talk about island architectures, this is one of the two topics in this talk, I want to see it from the perspective of, let's say, data flow and weight of transfer payload, right? So classically, what was happening is that we had a server, monolithic usually, right? And this server contains some data. It may be something like a state of the user in form of, I don't know, associated with a cookie. And it also then was able to generate a view. So in the end, generates just some large string that is HTML code that was transmitted over the wire. And at the end of the day, it was the client's responsibility, so our web browser, to display that correctly. And we started with pure HTML, but on this slide, we already see some CSS. So that there are the logos of HTML5 and CSS3. Don't worry about it. It's just, the logos we use these days. But what is meant here is just some HTML and maybe some CSS then end of the 90s. And this then changed a bit. So, of course, we started with some get and post requests on the endpoints that we had, and that have been, as mentioned, an endpoint that was able to generate a view. So the classic monolith, it got a little bit, let's say, broken up once we started to add more and more interactivity on the client. That all, of course, started already when JavaScript was born, but while we used it in the first, let's say, years only for simple things, I don't know, toggling maybe parts of the UI, an accordion control or something like that, it got out of hand pretty quickly. So at this stage here, let's say 2000, 2001, we start transmitting a little bit of JavaScript, and we still have a get and a post endpoint, right? And quite often that was also referred to as dynamic HTML, as Microsoft called it, DHTML, whatever you want to call it. So a little bit of sprinkles of interactivity in there, but nothing serious. So let's make it a little bit more serious, right? Let's bring over state also to the client, because once your client gets more and more powerful, suddenly you need also to have state. And state is here not only, let's say, interactivity state, that starts with, but suddenly the line blurs a little bit with the state that's also contained in the server. But we're getting a little bit ahead of ourselves. So let's first look. The JavaScript payload increased. We still have get and post endpoints. And potentially even now we have dedicated endpoints to retrieve some data. So here we are around about 2003, 2004-ish. Applications like Google Maps and Google Mail are entering the stage. and you want to retrieve also some data while the website is running. So you need those endpoints, and we have a split incoming, that we don't have the exclusive model of just view generation in the server. We also have now endpoints that expose the data directly. Great. The age of Ajax, or Web 2.0, has begun, and suddenly we are even talking about shifting things over. Why is that? Well, I mean, as mentioned, the state is getting more and more complex, and at some point in time, you are reasoning about, does it even make sense anymore to duplicate that, keep certain areas in sync, have the view generation on both the server and the client, and suddenly single-page applications become a thing, right? So you say, why should we invest in this duplication anyway, if all we can just do is shift things over to the client? And actually, that was a great success. I mean, not only did it create really dynamic web applications at the end, real applications, but also, and I think this is the most benefit we got out of it, the development efforts have been really shifted, and suddenly we got really great development tooling, because, well, it's all just in the client. We don't need to have now this duality, and we can really have a separation of concerns that also helps focusing now the tooling on certain areas. So if we have a front-end exclusive tooling, now that, well, is much more powerful than beforehand, where the tooling even didn't know where to start with, because it was just too complex of a problem. However, things can always, of course, turn really bad, really fast, and we've seen that these applications, they've grown out of hand. And so the question is, how can we make them more performing? What have we learned? What can we apply? Can we tame maybe the pattern beforehand? And as you can see, the bar with the JavaScript payload is now really large. The HTML bar is rather small. Okay, so the single-page applications that used the data endpoints now exclusively with a backend, great success, great developer experience. And the goal should be to reduce the payload of shipped JavaScript. And the idea is, of course, to increase performance, to have less JavaScript shipped, have it already pre-rendered, improve rendering times, and therefore overall have a better user experience. Now, of course, there are kinds of applications that don't care in this sector. They might be anyway hidden behind a login, and they are really application-like anyway. Spotify, Netflix, you call it. So for them, it wouldn't make most sense. But nevertheless, web shops and content-driven sites, for them, it really makes a difference. They don't want to be single-page applications. Now, where are we transforming to? Well, we bring the state back, but some state should, of course, be left. So we are back at the problem we wanted to avoid. And also, we got this duplication of the view again. Sounds like we are back in old troubles, right? But there are a few differences. First of all, it is all very tooling heavy. So the tooling should make this transition really easy for us. And second, all this duplication should not come at an extra cost. It should actually be rather progressively, and that is indicated here by the JavaScript that is now split up in different chunks. So what we want in the end is that we have an application that might come with some parts that either live on the client and the server, or that only live in one of the two areas, right? And the framework or whatever we use that makes this possible should take care of that. Great. So we got our endpoints again, and this is now what is now known as islands of interactivity. So instead of creating the whole application already in this puristic single-page application model, or we create it in this only server-side rendered model, we create it in a model that allows to have these parts, these regions, these islands, as they're called, of interactivity. So where JavaScript is actually used to hydrate them and get them interactive. So how is this happening? Well, there are several kinds of triggers that can be used in an islands architecture. Let's say our website looks a little bit like this. So we have a header, we have a footer, sidebar, and whatnot. Most of these things, most of these components that are indicated here, they can just be rendered on the server and you don't need to touch them anymore, right? I mean, there's a footer, it might have some static information. That's it. You just rendered it. There's nothing fancy going on here. But there might be things that are interesting, like carousel, for instance. It shows some images, but actually there's JavaScript being used. So every, I don't know, 5 seconds, the next image should be shown. That's, of course, something you can't do at the server. At the server, you prepare maybe the list of images to be shown, but you're not being able to just change this in the browser, right? So what you want to do is that you have a little bit of a JavaScript in the browser that just triggers a timeout and maybe changes some CSS classes or changes the document object model to go to the next picture. And what we want here is on loading of our carousel, we already start to trigger the functionality that we have this timer set. So we have a time-based trigger, so a loading-based trigger, sorry, that is pretty much starting immediately to enrich this component. And now our carousel is active and it also lives on the client. Now, for settings, for instance, it could be some kind of a menu that is maybe on the bottom of the screen and you're not always scrolling to it. But once you scroll to it, all the settings there, they might come also alive for whatever reason. And so another trigger that you might think of is a visibility trigger. So when certain things come into the viewport, you just load the JavaScript to make them interactive. You wouldn't do that beforehand because, I mean, if you don't see it, you wouldn't be able to interact with it. So it doesn't make any sense to just load the JavaScript. So you only load it, of course, when it's visible. So you have a visibility trigger. That's also possible. And now settings is live. We've seen it. So it just gets interactive. Finally, we could also have triggers like, when you type in something in keyboard or when you click it. So for instance, our menu might be some kind of a hamburger menu. So when you click it, we want to activate it. So suddenly we get all the additional JavaScript in there to make this thing actually live and hydrate it. And so at the end of the day, you could also have triggers that are based on clicking or on typing some text, or you can go crazy here too. So what all of these things have in common is that they are lazily loaded, right? We're not just bringing in the JavaScript right away. We have some special events that might be different per component. And when this event is there, we will actually go ahead and start loading the scripts for it. So we still need maybe a little bit of a script already coming with the whole web application just to orchestrate that. But that's all, right? So we need this little orchestrator. And this orchestrator then makes it possible to have all kinds of events triggering a lazy loading and this hydration. Now, hydration is a great great statement here, because what is hydration? Hydration at the end just describes that, we will activate some JavaScript-based component. And what you don't want to do is make a full hydration cycle, as is known, for instance, from React applications or from heavy single-page application frameworks, because that would involve loading all the components that are there. But as mentioned, we only want to load certain components, right? So there are two options for this. One is called a partial hydration. So you already know what you've all rendered on the server, and you don't want to hydrate now the same thing again, because, well, you do the work twice, and most of it just for nothing. What you want to do instead is you want just to hydrate some components, and not at the same time, but as mentioned, whenever you feel like you're ready to. You want to hydrate some components at their time. And this is what is referred to as partial hydration. And it works, I mean, even with a framework like React, you can make it work, but you need to put in some effort. And there are some edge cases that, what about now shared things? What about context and so on? So quite often it's a difficult problem to solve if the framework isn't ready for it. There's another concept that was now popularized by a framework called Quick. We will look at that in a second. That's called resumation. So instead of identifying now which components to partially hydrate, you still regard everything as let's say hydratable, but you're not hydrating everything. Instead, you resume from whatever you left off on the server, right? So you pre-render on the server, and the server has now all the knowledge, and now the server brings it in a serialized state, brings it over to the client, and this client, of course, has an orchestrator script again, and it can now make these smaller parts alive, just resuming where they left off. And the crucial part here is that you don't need to walk over things that have been pre-processed and they stay on the server, but you only walk over things and very naturally, just when they come across, when they need to be interactive. And so event handlers and everything, they just leave traces of strings in there, and they're always pointed back and reloading smaller parts. So there's a lot going on here in the engine with this resummation, and it transports back and forth some kind of a view state. So we are back at those things, right? But nevertheless, this is a really cool technique because it ensures consistency. The server, again, it rendered, it knows the full picture, and you're not having the drawbacks of partial hydration that some things might not work as you assume. Here it always stays the same. Nevertheless, there's a lot of work here in the framework to really make this alive. So what options do you have to use partial hydration, besides, of course, going on your own and trying to just implement it with the single-page application framework of your choice? There are three things that really embrace this. Marco is the first one. It also came up, you could say, with the islands architecture. So this is how it was born. And another one that very recently popped up is Fresh. So this is more like a demo framework for Dino, but maybe they will promote it a little bit more aggressively in the future. Nevertheless, it's really cool. It uses Preact to do partial hydration of the components. So everything feels very React-like, and then they just switch over, use the more lightweight Preact on the client. And then there's also Astro, which I always like a lot. It is more or less a static site generator, but it also can now these days use a full server-side rendering or come with endpoints. And in Astro, they really have a meta language on top that feels very much like, well, HTML, but a little bit with JSX parts in there. And then you can just use components out of any kind of framework. And they have, let's say, an integration with all kinds of frameworks that allows to actually partially hydrate them. So it's a little bit a lie because you still fully hydrate. Maybe then if you bring in a React component, you fully hydrate this React component. But since this is just one of many components among Astro, then yeah, we can still call it partial hydration. All right, so let's have a quick view at Astro just to see what this is about. I just use a small demo project that they have. It looks like this. So let's look at it up in the browser. So this is how it looks. It's just a block. And what it contains is a few pages, right? Like this home page has an about page, has also the blog posts in there, right? And what you can see on the home page is that you get this component here with the greeting, right? It switches through. So, I mean, this is all on the client side. So this thing is interactive and allows me to just go through it. And what I can do is I can, for instance, disable the JavaScript. Let's see. And now the button is not interactive anymore. So, well, that's it. Functionality is gone. However, what you can still see is the application itself was working. And of course it was, because it's fully pre-rendered. So you could say also fully generated on the server, or in this case at build time. But we got this one sprinkle of interactivity coming in. So how did they solve it in the code? Let's have a look. So Astro uses its own build system and all. It has a very natural structure already given. And in pages, we can see all the pages that you wanted to create. The home page is just the index Astro page. And it uses these Astro components here, like the base layout, to give it some structure. And now we also use here a component called greeting. It feels like it comes from Astro, but if you would look in the components folder, then you can realize, oh, that's, by the way, TSX. So that's using JSX. That's based here on, in this case, Preact. And this is all. Then we have a standard Preact component, and that's the end of the story, right? Now, this Preact component, it has some state. And of course, if we click through it, we've seen the behavior. It just shuffles through these greetings. Now, in Astro, we can use these special directives. Here it's called client load, which means also load this thing on the client. We can also ensure, for instance, that it doesn't render on the server. But in this case, of course, we already wanted to have it in there. Okay, so this is Astro. It allows us to really make some nice and fast websites using wherever we want to and wherever we need to, a little bit of interactivity, a little bit of JavaScript. And as a benefit, you can use multiple frameworks with it, which is quite cool. But just make sure that your preference should maybe not to hydrate all of them, but to render them on the server, because otherwise you will pay on the client the additional load. Okay. Let's continue with the option for resummation. As mentioned, there are not many because this is a relatively new pattern. I assume we will see more in the future because resummation is a really cool technique. The challenge, however, also as mentioned, is it's quite complicated to implement. Now, how does that look like? Let's do the same. Let's have a quick view at a demo using the Quick framework. And I think they got some more elaborate demos these days, but in here I just used one of the classic to-dos. So how does it look like? This is the demo application. It works really nicely. The benefit that you get, you can just see when you go into your DevTools and really open up the network view. Because once I do something, and let's say I type something in, for instance, listen to talk. What? Did I restart this? Let's clear it. Listen to talk, okay. We see that all these files are suddenly flying in. Because once I interact with this component, it needs to get interactive, right? And so we see that suddenly a few JavaScripts were flying in, including a really big one, just for development purposes here. And the thing just continues the more you interact with it, right? So I just now pressed the button, and again, some JavaScripts are flowing. The same holds true for sync clearing things, and at some point in time, you just grabbed everything and you have now the whole application. But keep in mind, all these JavaScript that are lazily loaded that the end user, of course, doesn't see, they're mostly really small. And second, they would have just accumulated to a big JavaScript payload if not following the quick approach. Other than that, what is here to say? I mean, it's a framework that feels very React-like because it's also based on JSX. So therefore, you've got all these templates, and of course, the notation itself looks quite cool. What you will see in this framework very often are things with a dollar sign. It always means delayed or lazily loaded, and this is a way how in Quick you denote how things will, or already can infer a little bit how things will flow later on to the client, which is quite good for a mental model. Okay, so this is the one side, performance. This is certainly something to keep in mind for scalability, but there's also another side, and that's a distribution of work. So as web applications were growing, you were not only like facing problems with the size of your web application, you were mostly facing problems with, well, the interaction of the team, right? Team was too large, and you needed to make sure that they were still working efficiently together. And this is where the pattern of micro frontends comes in, right? So you got the distribution of work where the claim is that 3 8-person teams are more efficient than one 24-person team. And that is true as long as the interaction between the teams is really minimal. So each team can independently create something and maintain it. Now, this is the other perspective on the evolution of web development. I just want to make a quick run through because essentially we've seen it all. We started with the monolith, then we separated, and that already allowed one big team to suddenly be 2 teams with a dedicated backend team. But the backend had more and more focus. So we said, hey, we need also to do something here. And the end result was, as we know, microservices. So now we can have dedicated teams for dedicated areas, so dedicated functionality, and that all works great, or doesn't it? Well, at least we structured the teams somewhat. Still enough technical challenges to overcome. And then we came up with micro frontends, which essentially is the same thing. But the cool thing about micro frontends is that suddenly, with your frontend also being modular, you could create full stack teams. So you embraced already microservices beforehand. The micro frontends just feels like the perfect addition because suddenly you don't need overarching teams. You don't need your monolith front-end team. You don't need maybe a dedicated operations team, a dedicated business team. Suddenly you create real verticals where all of these personas are covered. They're all in a team. So this is really great. This is why micro frontends present a great organizational pattern. They make sense when you already have a microservice backend, because why throw away this modularity by creating a monolith front end? Now, as mentioned, this organizational pattern has some charms, and the best charm that you get is that suddenly you can have independent development. So you might have a dedicated app shell team. So this is this gateway pendant for the front end. And they create something, they release it, and then they start working on the next version. Well, once they released it and once the application is out there, of course, now micro front-end teams can come, and they are fully independent of the release cycle of the app shell. So they also release, of course, with the first version of the app shell, but then it really doesn't matter. They have a new feature, they develop it. And the same holds true then for more micro frontends, especially if you use something like a micro frontend discovery service. That really makes a lot of sense. And suddenly you have a lot of independent teams that can all just create and maintain their solutions, and they all come together magically. So what are micro frontends from the perspective of a component model? Quite often I'm getting asked, what is a micro frontend? Is it one component? Is it multiple? Is there any relation to components? And my answer is a micro frontend is a container for components, but very special components. So let's say a micro frontend is in the organization orders. So that is a sub-team for orders. And the components that this micro frontend contains are what I usually refer to as domain components. So these are components that, of course, have some look and feel, but most importantly, they already have the domain knowledge. So that means that they, for instance, already know how to talk to your backend for retrieving some orders. Now, one of these domain components could be a cart button, for instance. So you're on the orders micro frontend, and one of the components that your micro frontend brings with is a cart button. So this is a button that, for instance, already knows to talk to the shopping cart. It knows how to read that out, and it might know how to update itself and do further things, right? But this thing is, of course, not alone. This might be composed now of functional components. So an example is an icon button, because you want to show this card button with maybe the design that was given by an icon button. But this is just a functional component, which means it doesn't know how to talk to a backend. It just knows how to represent itself and have, of course, some functionality in it. I don't know that, for instance, you can click it or that it changes its icon or whatever. But again, it doesn't have any domain functionality. It also doesn't care what is written there. Is there batch shown or whatever? But then again, this might be based on some atomic components, so things that you can't decompose any further, like a button, for instance. So it uses a button and an icon, and it makes an icon button out of it. I mean, this is, of course, just an arbitrary example, but this is the way to think about it. So you've got this structure, and what you expose, what you register from a micro frontend is not functional components. It's a pattern library. That's a shared library. You're also not doing something else. What you actually want to register are things that are domain components. So something visual with domain functionality. But these are micro frontends, so just containers of domain components. Now, there are multiple patterns, which makes discussion about microfrontends always very complicated, because depending on your kind of problem, a different pattern might fit. And you might start with something really simple, like a web approach where you use iframes and links to bring them together. And you might laugh about this approach, but iframes are still microfrontends. So if you include a chatbot from some third-party service and they're using an iframe to isolate properly, that's a microfrontend that you use. It's an independent team. You don't know these guys there. They are shipping independently. So you just include this one script, and oh, now there's a new functionality for our chatbot that we have on our website. That's a microfrontend. Now, server-side composition is already more elaborate and something you might even choose for creating your own microfrontend solution where certain things come together. This is great. Usually uses a reverse proxy. And then you can go over to the client, make client-side composition, use maybe a web component as a carrier here, or you might even go into something really like a nuclear reactor, like siteless UIs, which is a pattern I like always to advocate, because these are really independent, decoupled, and they are usable in multiple circumstances. So really, they are quite often not scenario-bound, and they create highly composable applications. But of course, it always depends what problem you try to solve. And then, of course, go for the solution that checks all the boxes or most of the boxes for your thing that you want to see being solved. All right. So let's have a look for one really simple UI using siteless UIs. But I mean, this example you could do with multiple patterns, and using a siteless UI as a pattern is certainly overkill, but just to show it to you. All right. So this is the demo application, and it's a simple drugstore store. This is an example taken from microfrontends.org. So thanks for the resources, Michael. He has also written a great book about it. And what you can do here is you can also inspect the network tab and see what's going on. So let's just do that. I refresh. And this thing is hosted here at GitHub, so we get a 404, but don't worry about it. That's just falling back to the index. So single page application is done. All good. And we load a script here. Sorry if you can't see that. Let's make the waterfall a little bit smaller. Well, let's just increase this. Anyway, so we load a script. And this script has the orchestration. So it knows already what to do next. And the next step to do is to go to a discovery service. And the discovery service is hosted at so-called Pirate Cloud. You shouldn't worry about it. But the thing you should worry about is what you get back from calling the discovery service. What you get back is a list of microfrontends to include. So you get back, for instance, there's Team Blue, there's Team Green, and there's Team Red. And these are 3 microfrontends. And they now come together. So we load then the scripts for these 3 microfrontends, and at the end of the day, what you end up with is this solution. So it was just composed together by the 3 things. Great. So now you have a single page application. You can click around. It just works. It updates it. You can now add things to the cart. Now this is all just components. React, I think, used here as a framework, and they're all just working together. Great. You could also, of course, go into the feed service. We might do that later, and say, now I just disable a microfrontend, and you will see the same application keeps on working. But one important thing to do is let's disable also JavaScript here. So we did it beforehand with Astro, and it was working to the extent that greetings wasn't working, of course, but the rest was just working. Now, this thing here, if I refresh, I disable JavaScript, there's just nothing loading. And I mean, it makes sense because without JavaScript, no orchestration script. Without an orchestration script, no further microfrontends loaded. Without microfrontends, well, an empty application. So not really what you want to see. Plus, we don't have any state here. I mean, as mentioned, it's just a static web app. And that's how you can roll here. And we will see this thing changed up a little bit in a second. Now keep that in mind. So this is what you get there. Quite a good user experience. You don't see that there are micro frontends. Sure, we dotted here some lines, but you don't see that usually, and it just comes together magically and it works really nicely. But there are these drawbacks that we've seen. We need to transport some JavaScript and so on and so forth. So now, finally, where do the two things now come together? We've seen islands, which is, well, a technical pattern. It already described many of the things that you need to see. For instance, need to be server-side rendered, because otherwise interactivity in the client doesn't make sense. If you say, well, you can also just do everything on the client, there's no need to do server-side. Therefore, islands are really a technical pattern. And microfrontends, on the other hand, well, the pattern wasn't really cut in stone. So microfrontends are fully organizational. It's really all about how to organize teams. Now, technical implementation of that just should solve your problem. So, for instance, if you have a web shop, you will usually aim for server-side composition. But nevertheless, so this is just organizational. And yet, I claim that there is an overlap. So how can we see that? Well, let's say here's islands. Here's what it offers to us. We have server-side rendering first. It's rather minimalistic, so really just sprinkles of interactivity. We use something like resumation or partial hydration, and we always want to lazy load things, right? And ideally, if there is nothing to be hydrated, and we already know that because we server-side render, don't forget that, we shouldn't ship any JavaScript. So we don't even ship the orchestration layer if you already know there's nothing to orchestrate later on. Great. We also make use of placeholders potentially because, yeah, things might change and we already want to be able to orchestrate things. Now, these are islands. Now, let's see it micro frontends. And certainly we will need to keep less of micro frontend of the whole solution space of micro frontends than from islands. Here we will potentially use everything. And let's see. So micro frontends are distributed. This is certainly a property we can also use with islands because no one tells us how the team structure should be set up. We might have something like a proxy or reverse proxy. We can use certain strategies for our server-side rendering too, so it makes sense to also include it here. Orchestration layer, that also sounds similar to islands. And scalability is an important aspect here. Okay, might be also on the boundary. Lazy loading, this is where it gets interesting because micro frontends also tend to lazy load many things. Otherwise, it just doesn't fit well together. And micro frontends allow to have a tech mix. But by the way, we've already seen tech mix with Astro as an example. And other island architecture powered frameworks are going in that direction too. So tech mix is also something that should be allowed. And this might live on the intersection. And placeholders is also something we see quite often with micro frontends because you got some scenarios where you say, hey, there's this one micro frontend, and it might show, as we've seen here, we got this page from the tractor, but the product page, but it also shows then things like recommendation or our basket icon or the buy button, right? So it already included placeholders that other micro frontends might introduce components here. And so it's also very similar. And therefore, we, I think, already identified a perfect boundary between the two. We need to use server-side rendering, of course. We might want to go for partial hydration. Resummation in general wouldn't work, right? It might work within a partial hydration, but since we don't know what is the technology or framework behind, in general, we would just go for partial hydration. And we use decoupled with multiple teams. So instead of having everything in a monolithic build, we want to have it in decoupled distributed builds that can be done by many, many different teams. So how could that look like? Let's have an example. And we choose the same store again, right? It's the same thing, essentially. Let's use this one. And let me open the developer tools again. First, let's see how the thing behaves. It could have changed quite drastically, but what I decided is that we have a multi-page application. So when I press now on a link, it goes to a new page. That's a complete reload of the page. that's fine. You can still implement that, let's say, a single page application style that it does this all in place, but I kept it like this to show this character. But what I changed definitely is I can now press a button and well, it updates the store. Now, if I change the page, you will see that the basket still remains at 7 items. And that's no mistake, because now, of course, we're working against server-side rendering, so we can also use the server-kept state. And when we press this button, I mean, it still feels like snappy as with the single-page application, but it also sends the state and synchronizes it with the server. And this is also where one advantage lies, because now if I go in here and I disable JavaScript and I reload, it still works. And I can even press the button, which now is again a full page reload, because this is not just a form post, right? We can't send it now via JavaScript. We're not getting this smooth experience, but the behavior is quite nice. So what we have here is that everything that we've seen beforehand is rendered on the server with the blue micro frontend here rendering its components also on the client in addition to it, and then of course hydrating them when it makes sense. So how was this done here? Let's have a look at parts of it. So we have the 3 micro frontends. They are also deployed independently, and I can show you that in a second, that I can switch them off to. And if we look, for instance, at the green micro frontend, what it does is it registers a component called recommendations. This just is the product recommendations. So you will see it in here. Bring some links in, but then it's just a little bit of React code, right? So nothing special. And what it does is it even makes an annotation to say, I don't need to render on the client. So it will not ship anything. It will not partially rehydrate on the client. It will only render on the server, and that's it. And that's a contrast to, for instance, what we do with the blue micro frontend. Now here, we also register a store, call it card, and register 2 components. One is called basket, the other is called buy. There's no annotation here. And that means that, these components will also render on the server, on the client. Right. Also looking at the time, they will not have time to go into all the details, but there is a publicly available repository. I will give out the URL at the end of the talk, so you can just inspect the code yourself. The end result is clear. You get great performance, like the best performance you can think of. Actually, that even could be improved in my opinion. So there could be also zeros down there. But nevertheless, so the idea is that this is really, really fast, and it just renders as fast as possible. How does it work, let's say, from a high-level point of view? So we have our server. The request comes in. It creates a state. I mean, it looks up first if there is already a state available, because we know the session, right? And then we load the micro frontends for this request. There might be different ones, so you can still distinguish per request what micro frontends you compose. And with the known micro frontends, you start to render. So you have all your components now assembled. That means you can start to render. While you render, you already start to gather some state. So at the end of your rendering, you will need to serialize that, put it in some script tag, and ship it to the client. Now the client will, of course, get the pre-rendered side, and it also comes with a little bit of an orchestration script. Now that looks at the given script with the serialized state, it initiates the loader, and it resumes that state. So here resumation is in there, but make no mistake, that's not the component resumation, that's just of our, inter-component layer, so to speak, of our micro frontend layer. Then the components that need additional hydration, like component 2, for instance, in this diagram, needs to be hydrated, and we start the hydration. We can still have all the annotations that we've seen before on visible, for instance, or whatnot. Media changes, you can go crazy here, and then we get interactive. Before I conclude the talk and go to questions, I want to show also now how it looks like if I disable something. So let's say I disable the blue micro frontend, but let me also enable JavaScript here, just that we get a smooth experience. So yeah, let me just disable this one. I hope that's the right thing. Yeah, and we see this is now gone. Just for you. My machine is on the edge. But what I did is I just pressed this knob here. So I could do the same, for instance, for the microphone in green. And if I now refresh, so you see this is now a really dull experience. It still works and it should still work. I mean, it's microphones, but the composition just looks different, right? And of course, we can just reactivate both. Let me just do that. And I hope that now we are back again, right? And yeah, this is how you might think of it, that it just is able to compose on the fly. And with this in mind, I want to close the talk, and I'm now happy to take to take some questions. Thanks a lot, everyone, and have a great conference.
Thanks for that, Florian. Really interesting discussion. Actually, very insightful. So, guys, if you do have any questions for Florian, get him that Q&A quickly. I'm aware that people want to get towards their lunch break because they probably want to get some food in their belly. But before we do that, we've got to get some food in your brain. I guess I'll kind of open up by kind of inquiring, Florian. It seems like an interesting process, but I'm sure the implementation, is different to what a lot of people are familiar with. So maybe you could talk a little bit of the challenges you've experienced with implementing the island architectures.
Yeah, so the main challenge is usually how you do this hydration layer, right? So because as mentioned with React, you got this big bang, so to speak, and this is one thing that also, for instance, Next.js faces a lot. They make the two builds. They make one for the server, and they make then a bundle for your client. And of course, they do then some tricks, and they don't want to let's say, the full bundle always available, so that they make smaller bundles than for each page, etc. But nevertheless, the basic idea is how can you just, starting with a big something, come up with lazy loading of smaller components. And this is, of course, where all of the work of now these new frameworks like Quick is flowing into, right? They also try to come up with something innovative here because, I mean, again, the problem is not just you just see some components. You can always just pick one out and say it's easier, just render this thing later. But then suddenly in the more complex applications, all these edge cases come up where there's a context that's already on the root of your components. There's something else happening in another component. So how do you now bring all of these things together in a consistent way and still have, of course, lazy loading without even the developer needing to interact here and say, this is where I want to lazy load, or this is the granularity, and making it really granular. So, yeah.
Interesting. Yeah, so it's fair to say, like, there's obviously the teething issue of kind of getting used to developing in this sort of format, right? For people that aren't used to it. So there's obviously going to be a pickup kind of time. In terms of resources, like to kind of learn on this right now, right? Like, how many people are using this? Is it more or less just you guys at the moment, or are you already seeing a lot of people picking up this process you just presented today?
So what I presented today with micro frontends intersection to island architectures is completely new. There's at the moment no framework out there, and Pyro will be. So this is a little bit a teaser, so to speak. We will reveal a new generation of our framework soon that fully supports this. You can still, what you do today with Siteless UI, single page application mode, microfrontend composition, you can still do, and we have a lot of users on that basis. And you can't just migrate from one to the other because the words are just a little bit too different, but you could then either start a new project or maybe think about migration. Maybe it makes sense. And yeah, we will be the first framework to get that out. I mean, as mentioned, there are many frameworks for island architectures, but none of them support the distributed development. They usually want a tight integration. And yeah, I think this will be quite cool when we come out. But the demo's already there. And I mean, the demos don't use already the framework. They use something just composed on the fly. You can just see it and maybe use it as an implementation basis for yourself.
Yeah, and I linked that to the people in the chat. They want to give it a look themselves. I think we've got enough time for one more question. We've got one coming in from Paul. They ask, what would you say are good indicators when one macro front end should be split up into micro front ends?
Yeah, that's always a great question because there's never a great answer to it, unfortunately. So they are just an indications, right? As long as you are happy with it and you say, "Oh, this is working well. We are fast." Yesterday there was an issue. We were able to fix it within a couple of minutes. Everyone was happy. There are no indications that you should change that. But once you hear sentences like, "Oh, we can't deploy because this one feature," or "we need to do more alignments," or "we are already weeks behind, we can't just do a hot fix because of this or that," that all might be statements that indicate that maybe you already should break up your monolith and go to smaller pieces. And usually a good way to do that is progressively, not just, go in and let's make 90 microfrontends, you're happy, but just cut out the pieces that maybe have more changes than others, because you want to set them on their own track, right? That they can release more faster than the big one. And then you can identify these pieces. And when in the end you remain with something that rarely changes, that is a good app shell, because it should rarely, if ever, change. And then all the microphones, they have then faster cycles, but they are then driven by individual teams, or maybe not individual teams, but at least have the individual cycles of maintenance.
I think we always want the kind of cookie cutter answer, but I think you gave a good guideline for requirements for that breakdown. So thank you for that. And thank you for the talk, Florian. It was absolutely wonderful, very insightful. And I'm excited to see what you guys are able to do with this. I think there's going to be pure fire. So definitely going to be keeping an eye on this in the future. If you guys do have more questions, if you want to reach out to Florian, his details are right there to our side. Be sure to do so. As you can see by the big smile on his face, he's more than welcoming to have questions come his way. But folks, I think it's time for us to break for lunch, if I'm not mistaken. So we're going to be back in about an hour. So get your bellies full, and then when you come back, we'll fill your heads with even more knowledge. But Florian, absolute pleasure. Thank you again.
Thanks. Bye.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and I am illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to stay with